Hello, so we're going to do some examples with the quadratic formula in case you needed some extra help with that. The examples are going to kind of get a little more complicated as we go, so if you want to skip ahead just to see the more complicated ones, go ahead and do that. Otherwise, you can watch the whole thing if you got to see some, if you want to see multiple examples. So this first one's asking us to find the x-intercepts. Now, x-intercepts, right, are always something comma 0. So we can plug in that 0 for our f of x or our y. So we would have this. And then once we see this, we can kind of automatically be like, oh, great. It's in standard form. It has an ax squared, a bx, and a c. So let's use the quadratic formula. So our quadratic formula, let's remember, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And let's remember that gives us x values, which, I mean, if we're looking for x-intercepts, we're looking for that x value. So let's plug it in. So we got the opposite of b. In this case, our a is 5, b 33, c negative 14. So the opposite of b is the opposite of 33, negative 33, plus or minus the square root of b squared, so in this case 33 squared, minus 4 times a is 5 times c, negative 14, all over 2 times a, 5. And again, this is going to give us the x values. And now we're going to start simplifying, right? So we have the negative 33, we'll have the plus or minus. The denominator I can do in my head, right? 2 times 5 is 10. The part with the square root, I'm going to want to do on my calculator, right? So remember, first, we just do the stuff inside the square root on our calculator, right? We don't include the square root. We're just going to put in exactly what I highlighted. 33 in parentheses squared minus 4 times 5 times negative 14. Now, I can't show you my calculator on here like I can at school, so you're just going to have to do it along on your own calculator, and hopefully you'll get the same number as me. But I'm going to type that in exactly as I see it. And I got 1,000, oops, let me get my pen. I got 1,369. So what I'm going to do first is I want to check, okay, before I try breaking it down, let me just see if it's a perfect square. So I'm going to do the square root of that number now on my calculator, 1,369, and I'll see what it gives me. Oh, it gave me 37. How nice. So in this case, I don't even need to worry about like breaking down because I know it's going to give me a whole number, right? I typed it in my calculator and it gave me a whole number. So we're going to have negative 33 plus or minus 37 over 10. All right. Now, because these are both whole numbers, we can combine these. So we're going to break it into two. We're going to do negative 33 plus 37 over 10 as one of our answers. And we're going to do negative 33 minus 37 over 10 as our other answer. All right, negative 33 plus 37, well, that's 4. So this becomes 4 over 10, or 2/5, which would be one of our answers or one of our x-intercepts. And the other one, let's see, negative 33 minus 37, I think that would be negative 70 over 10, which becomes negative 7. So that would be our other answer. So our two answers here, right? Because remember, we're always going to get two answers with quadratics. Our two answers are 2/5 and negative 7. All right, let's look at another one that sort of adds in one little extra piece here. So this next one, you'll notice, find the roots. That just means, roots just means solutions, right? Find the solutions or solve. Now this one's a little different because some people are going to want to jump in right away and say, oh, A is 3, B is 4, C is negative 12, and then they're going to get it wrong. So don't be that person, right? We always got to get one side to 0 first. So in this case, I could either subtract 3x squared from both sides, or I can subtract 4x minus 12. It doesn't matter. You can do either one, right? In this case, hey, I'm lazy. There's only one 3x squared on this side, so let's get rid of that. That way I only have to move one thing instead of two things. So this side, those cancel. All right, now I cannot combine 4x and negative 3x squared because one of them is squared and one of them isn't. So I'm just going to have negative 3x squared plus 4x minus 12. So notice all that really changed was now my a is -3 instead of +3. And then we plug into the quadratic formula. So we have x equals the opposite of b. Opposite of 4 is -4. Plus or minus the square root of b squared, 4 squared, minus 4 times -3 times -12. All over 2 times a, -3. All right, we're going to start simplifying, same way we did before, right? We can start by just doing the denominator in our head. 2 times -3 is -6. And then we will do the inside of the square root just on its own first. So again, plug in without the square root, just the stuff inside the square root, right? Just the discriminant. Plug that in. So we'll do 4 squared in parentheses minus 4 times -3 times -12. That gives us -128. All right. Now, in this case, if you tried to go and do this on your calculator, it's going to say error, right? We have an issue here. We have a negative inside the square root. So we're going to have to break this down and figure that out. So again, first we're going to take out the -1. We got 128. That -1, we got to remember, is going to become an I. And then we just keep breaking down 128. So let's see, it's even, so I know 2 goes into it. What would that be? That'd be 64. 64 is 2 and 32, 2 and 16, 2 and 8, 2 and 4, a lot of 2's here, and then 2 and 2. Whew. Okay, so there's a lot going on. Let's see. Let me cross out the things I already broke down so I don't count them twice. And then let's start looking. So we got 1 pair of 2's, 2 pair of 2's, 3 pair of 2's, and 1 2 left over. So this would become x equals -4 plus or minus. Now remember, pairs go on the outside. So we have 3 pairs of 2. Some people might be tempted to say 6 there because they're like, oh, 2 times 3 is 6. Again, don't be that person. We got to multiply it. 2 times 2 is 4. Times another 2 would be 8, right? Because we got to do 2 times 2 times 2. That's where I got that 8 from. And then we have a 2 left over, so that'll stay in the square root. And then we don't want to forget that negative means we're going to have an I. All right, so we got this. We are 90% of the way there. To finish, we just got to simplify. So we'll break the heart. So our first fraction would be -4 over -6, right? We keep the plus or minus, and then we break the second make our second fraction. 8 square root of 2i over -6. All right. -4 over -6. Negative over negative becomes positive, so that'd be positive 2/3. Plus or minus 8 over -6. Let's see, 2 goes into both of those, so it'd be 4 square root of 2i over -3. So this would be our answer. All right, again, we got 2 answers here. One is 2/3 plus 4 square root of 2i over 3, or -3. And the other one is 2/3 minus 4 square root of 2i over -3. All right, but again, I'm okay with you leaving it like this, just as one thing. But no, that's 2 different answers. All right, last one, we'll step it up a little bit more once again, and then we'll call it a day. So this last one, we got to solve. Now again, we don't have an equal 0, so we got to do that first. Now, if you watch the square root video, you might have noticed, hey, in the square root video, we weren't able to distribute. And that was because our parentheses had squares. In this case, our parentheses don't have squares, right? There's no squared there, which means we are totally free to distribute here, and we actually should distribute first. So we're going to distribute. 2 times 4x squared is 8x squared. 2 times -5 is -10. Then on the other side, we got 3 times 2x would be 6x. 3 times -4 is -12. All right, we got rid of our parentheses. Now we got to get one side to 0. So let's get the right side to 0. So I'm going to do -6x to both sides. Now, I've seen some people have written it this way, all right? 8x squared minus 10 minus 6x, which is fine, right? And then they did plus 12, and they go, oh, well, I can add the 12 to the 10, so they'll change that. Minus 10, they'll change that to a plus 2. Now, this is totally fine. You can do it this way. If you do, though, be careful about your ordering, right? Because a lot of times then people are going to go, oh, this is A, B, and C, and they're going to be totally wrong, right? Remember, the order doesn't matter for A, B, and C. What they're connected to matters, right? So A is always connected to x squared, B is always connected to x, and C is always alone. So if you write it in this order, that's fine, but make sure you know that actually your B in this case is that -6, and your C is the 2. All right. Now, I always just like to write it in the right order, so I always like to do the x squared, then the x, then the constant, so I don't get my A, B's, and C's confused. But as long as you figure out what your A, B, and C are correctly, the order you put them in doesn't really matter there. So let's get to solving. So we know our A is 8, our B is -6, and our C is 2. So let's plug in. So the opposite of B, opposite of -6 is +6, plus or minus the square root of -6 squared. Again, make sure in parentheses, times 4 times A times C, all over 2A, which is 2 times 8. All right, start with the stuff in your square root. So we'll have 6, oops, let me get my pen. So we'd have 6 plus or minus the square root of something over 16. Let me go to my calculator and make sure I put it in parentheses. So -6 in parentheses squared minus 4 times 8 times 2 gives me -28. And then it's time to simplify. So get rid of the negative. 28 becomes 2 and 14, 2 and 7. The -1 will become an I. We have a pair of 2's and a 7 left over. So we'll have 6 plus or minus 2 square roots of 7i over 16. And we just got to break the heart and simplify. So our first fraction will be 6 over 16 plus or minus 2 square roots of 7i over 16. And then we simplify. So 6 over 16, let's see, 2 goes into both of those. So we'd have 3/8 plus or minus 2 goes into both of those. So we'd have 1 over 7. Or sorry, not 1 over 7, 1 square root of 7 over 8i. And these would be your answers. So hopefully that was helpful. If you got to go back and rewind and see any of these, or if you have any questions, message me and let me know. But hopefully this gave you some clarity with the quadratic formula, and I will see y'all later. Bye.